G'day.
Hi, how's it going? It's nice to see you all again. And actually, I fixed the screen up a bit so I can see more of you, which is lovely. So we've got Betty Moon Cole, and I think we've got a few. Vanimo, hello everyone there as well. It's nice to see you all. Fantastic. So we're really excited to be doing our second workshop with you all. I think we had to rush, unfortunately, the last workshop. So we wanted to do a bit of a recap of what we were covering. So should we get straight into it?
Yeah.
Yeah. So at the end of last session, we were talking a little bit about, no spoilers, sorry. We were talking about a very, very important constellation, which is Dark Emu. And I think maybe while we're waiting to see if we can fix this, if you remember, we gave you there was that lotus diagram that we were asking you to have a look at with all the different themes. So if you have got that, perhaps what you can do is just in the chat feed, you can list a couple of the themes that we spoke about as being really important in terms of telling stories in Indigenous culture. If you don't have it in front of you, that's fine, but maybe you can remember. Just pop that into the chat feed while we're waiting. Those themes, though, are still quite important. So if you do remember what those themes are, feel free to chuck a few of them into the chat feed. I might get us started with one just to get you thinking. One of the themes was animals. Okay. Does anybody remember what some of those other themes were that we spoke about?
And so that lotus diagram was that collection of sort of like a grid where we could group all the themes and sort of see the way that they might connect with one another.
So it looked, I don't want to show them the grid because that'll spoil it. We're trying to get you guys to remember, but it was the colored grid, or black and white, depending which one you're looking at. So one of them was animals. Does anybody else remember some of the other? The constellations of stars. Well, we were looking at stars as a mechanism for telling stories?
Yeah, so we're looking at some of the different constellations, and in particular looking at this idea of dark sky constellations. And it's the themes that exist within those stories that we're trying to talk about here. So we essentially had a collection of 8 different themes that essentially, when we're looking at Aboriginal astronomy, it's never just about the astronomy, it's never just about the skies, but actually it's quite often telling us about one of those 8 themes. And honestly, probably more beyond that 8, but that's what we have. And so animals was one of them. And you can see that with the emu in the sky that we looked at last time, or the dark emu, because it's not just an emu in the sky and that being part of the theme, but it's also telling us about the animals on the ground, about the emu. And so, as Miss Boney put in the chat, animals was a key theme.
Yeah. Does anybody remember some of the other themes that we spoke about?
Does anyone still have access to the lotus diagram?
Brett's got plants, yes.
Perfect. So plants is another key theme. I always think of animals and plants as sort of true halves of a whole. But yes, plants are really important. And we did look at, I know one example that we had last lesson was looking at the way that the Pleiades, or the 7 sisters, actually tell us when we can harvest certain plants on Ngarrindjeri country here. So plants is a key theme as well, and one of the ones we looked at last time.
Yep, weather was another one. So that there could be information about the weather, maybe forecasting the weather, or maybe to do with seasonal weather changes as well. Yep, absolutely.
It's perfect. And so keep that lotus diagram in mind. The first session, we covered a lot of different topics. Today, we'll be able to add to some of those topics. So it's good to keep that at the ready and see if you can expand upon filling it out.
Yeah.
And then also for the third session as well.
Because what we really want to do is we want to start, building this idea that stories aren't just stories, and they're not necessarily just teaching us about one thing, but many, many things. and to tie in those ideas together. So yep, we've also got their country as well. Country is another really important aspect. But it's interesting when we use the word country, what do we actually mean by country? And that's actually quite a big question, because it's not just saying, oh, the country of Australia or the country of, Papua New Guinea. It's so much more than just a place.
It's a concept with a lot of depth. I know in Australia, when people are used to hearing the word country, when we talk about Aboriginal people, instead of thinking of like Australia or Papua New Guinea, they're going to start thinking of, they must literally mean the different countries. So like I'm Gomeroi. At the moment, you and I are working on Boonwurrung land. When I go to my other job, I would be going onto Wurundjeri country. But once again, that's still a shallow way of looking at it. Country is our word to describe everything in the universe. It's literally almost synonymous with the universe. Essentially, not just the land that we're on, but every animal and plant, every human involved in that.
And it's also a relationship almost as well. It's a relationship of living in that country as well, and your relationship with all those elements of the country. Yeah, I think, yeah.
And so these stories that we've looked at can tell us a bit. I know the emu in the sky can tell us about the way country is changing across that. In relationship with that constellation. So
yeah. So what I'll do quickly is I'll just flash up on the screen the lotus diagram, just to remind you that we have these themes. We've got animals. We spoke about animals, plants, weather, country. Navigation's another one, in which we will look at in a lot more detail in the last session. We've also got a little bit of ceremony, which we might talk a little bit about today. And things on social values and history as well. So these are just some of the themes that might be addressed in some of the stories that we're going to tell. So I don't want to spend too much longer on this, because I would really love for you to be able to fill this in as throughout the course. It's not just something that I want you to do for one activity and throw away. I'd like you to please, be thinking about this as we go through all the stories, and some will have an emphasis on one thing more than others, but just be keeping that in the back of your mind. So let's just talk a little bit. Let's listen to this story of Dark Emu. We're going to try playing it, I believe. Should we see how that works?
I'd just like to talk about some traditional knowledge that was handed down to most of us Indigenous fellows in this area, and it's the emu in the sky. Around April, May every year, the emu will appear in the Milky Way. Just underneath the Southern Cross, you'll see a dark spot, a rounded dark spot. That's the head of the emu. In front of him, of course, is his beak. And as we follow it down, you can see his neck in the dark spots of the Milky Way. Comes right down to his body. You can see his legs, and you can see a couple of eggs underneath. At that certain time of year, it's the time for us to go out and collect emu eggs. We go out, of course, into the bush, always leaving some eggs for next year and for the generations to keep going. They only last up until early June. Anytime after early June they start getting chicks in them. But before that, from April, May, you're pretty right to go gather.
Thanks for that. Okay, I love hearing that story.
Yeah.
I think it's really pretty. Could you all see the emu in the sky at the end there when they showed that last image? I think it's really interesting because normally when we're looking at constellations, we're looking for the bright spots, but in this case, you really need to be focusing on the spaces to see the emu and to see it clearly, which is really nice.
Yeah, no, I definitely agree. The Milky Way is a treasure, so it's nice to be able to see it and to have a different way of looking at the skies.
Yeah.
Yeah.
So maybe we can have somebody share with us, was there anything in there, any themes that you picked up on that might be teaching us about the world around us? I can see some talking happening at Benemo. Anybody else have any ideas?
There's probably one like more obvious one.
One very obvious one, and that's the right answer if you wanted to share that one.
It's also worth noting that the story, as Ben Flick told it, as well, has a lot more layers and detail to the story. If we have a proper yarn and sort of get into the level of detail in it. Other thing, I don't know, is it, we sort of went over them last lesson. I don't know whether it's worth going over those slides again or not. Yeah,
well, look, I mean, if we talk about it, we had obviously, talking about the emu. So we've got something to do with animals.
Mm-hmm.
There's also an element of, I guess, social values, this idea that we're living in balance with the world as well.
Yeah.
So we've got this idea that we are, we go out and we collect eggs, but only between certain months, because if we go out any beyond that, then we're actually impacting on the emus' populations.
Yep.
It talks us a little bit to us about social values. So they value this idea of living in harmony with country.
Mm-hmm.
It also teaches us something about country because we're living on the country and we're living in relationship with the country that we're on.
Sustainable harvesting is another good social value. So we said always taking what you need but leaving enough for next year.
Mm-hmm.
And then also some of the details we would have spoken about last lesson that he may not have necessarily covered. We spoke about how the orientation of the emu will change throughout the year and how it'll tell us when eggs are ready for harvest or not. And one of the final descriptions that we used was that the emu is changing where it is throughout the year in its orientation. But in the summertime, it's not, when we go to look for it after sunset, it's not actually high up in the sky, it's actually down below at the horizon. And so this is said to be that the emu is this big bird in the very hot conditions of summer who's lowering himself down into what we call the water hole of the horizon. And he's acting it's sort of like if I filled up a bathtub way too high and I hopped in and I pushed the water out, that's what the emu is doing as well. It's this huge celestial bird that's pushing the water out of our water holes. And so this is another description for what's happening on country, with the changing of our beautiful, lush environment into something that's a bit more dry and a bit more arid, maybe not as nice, so that the emu feels the need to hop into water. So it's a good example. There's heaps of layers of knowledge in just that one story alone.
Yeah. So what we're going to do today is we're going to start looking, I guess, exploring a few more astronomical sort of events that occur and that are observable. So we wanted to start off today just getting you to think about, if you were an astronomical object, what would you be? So for instance, if I was to be some sort of feature in the sky, I would like to think of myself as the sun, because I'm just so bright and I just am so warm. That's what I would go with. Crystal, what would you be?
That's a tough one. I would like to be Venus, because Venus is very bright, so noticeable, but is very special. Sometimes we see it in the morning, sometimes we see it in the evening. And I think that's good.
You
that's
just pop up randomly during the day.
I just pop up randomly.
Pop up whenever. Yeah.
So
what I want you to do, maybe it's just quickly in your group. So I'm going to spend a minute on this. I want you to think, if you were an astronomical object, what would you be? And I want you to share it with the person next to you. If you are on your own, share it in the chat feed. If somebody in your class is going to be something really incredible, get them to share that in the chat feed as well. But just have a quick chat. If you were any object in the sky, so a planet, maybe a black hole, maybe a supernova, maybe a shooting star, a meteor, just to give you some examples. What would you be and why? I want to know. I'm really curious.
I just thought of a pun.
You thought of a pun?
Yeah.
No, you didn't.
Yeah, I did.
Okay.
Should I say it?
I don't know. Yeah, go for it.
Oh, no, maybe I'll wait to see what others say.
What other people say? I'm really curious as to what people are going to come up with. Venimo Secondary, you guys look like you're having a fantastic chat, and I really want to know what one of you wants to be. Bertie Mumcole as well. Anybody have? Oh, I see some typing. This is good. I like typing. Feel free to unmute yourself as well if you'd like to share your astronomical object. But I want to be a shooting star because I will travel places within the blink of an eye. Yes, like that.
Beautiful.
Yeah, it's very efficient of you. You'll never be late for anything. You'll just be there on time. Yeah. Never late. Excellent. Any other offerings before Crystal regales us with her pun? I want to hear the pun now.
Do you want me to say it?
I don't know. Yeah.
It's sort of self-deprecating.
Okay.
I just found it funny.
Okay. I feel like this is going to be very... Go.
I feel like I would be a black hole because I'm very dense.
Oh.
Dense sort of meaning, a bit silly. And black holes are the most dense objects in the universe. They are the most amount of matter you can imagine squished into such a small thing.
Yeah.
So, yeah.
I think it's important that we all know what we want to be in the universe. I think it's important. One of the stars in the Southern Cross, a leading light in the sky, Brett.
Oh,
You want to be a leading light? You are a leading light, Brett.
I love that. I also love Sophie's more sort of optimistic take as well, mysterious. It's like,
So Sophie's like, I want to be a black hole because nobody would know anything about me.
yeah.
And try and get a picture of me and I look like a donut
Yeah.
that glows. So I love that. Excellent. Okay, so now that we've now, very important. We've had a bit of fun now. We're going to get serious. Your projects. Dun, dun, dun.
It's not all fun and games. We are
We are
projects
doing
and
the projects. Yes, it's very serious.
Also
I feel
a lot
like
of fun.
Also a lot of fun. It's going to be so much fun. So we've been talking a lot about the importance of storytelling and storytelling as a mechanism for storing information, as a mechanism for transferring information, and communicating values and ideas and themes, okay? So what we would like you to do for your project is we want you to research an Indigenous story that might be from your local community or maybe a community that holds some sort of significance from you. Can you all read that text that's up on the screen there, or is it a bit blurry? It's okay? Good. So the challenge is to research an Indigenous story from your local community or a community which holds some significance to you. So it might be local, it might not be, it's up to you. And the story doesn't necessarily have to relate to astronomy or astronomical events, not astrological events, astronomical events. That's a typo there. Because obviously, if you can find an astronomical story, that's fantastic. But if not, that's fine. We just want you to find a story. And it could relate to social practices. It could relate to plants, to weather events, to animals, to social values, or anything. It's just something. Its original form doesn't have to be a story either. It could be a dance. It could be a song or a piece of artwork. Okay. It could even be knowledge that you've learned from an interview or discussion. So it just has to be, basically, we're looking for you to find out something that is some sort of information. But what's important is that it contains some of these interconnected themes we discussed in workshop 1 and at the start of this one. So animals, plants, weather, country, ceremonies, cultural values. So it needs to contain some information. And what we'd like you to do is we want you to retell that story. So you have to take that story that you find, the original story, and retell it in another form. So it could be creating a picture book story of, you know, an interview or discussion you've had. It could be making an artwork of a dance or a story that you know about. So be as creative as you want. We want your talents to shine through, and we really want you to take ownership of what you're doing. If you are an incredible musician, write a piece of music about the story. If you really love to sing or to dance, you know, feel free to incorporate that. You could just write a book, which is just as valid. You know, do something. What you just need to consider is that you just need to make sure that it's able to be captured digitally. So, you know, taking a video of it, uploading it on something that can be uploaded if it's a document. Okay, does this all make sense so far? Can I get like just some nods or thumbs up or yeses in the chat feed? Yeah. Okay. So to go with this, because we know that some of you might be saying, okay, I've got this amazing story that I know from my local community. I really want to share it, but I want to put it in the form of a dance, or I want to draw a piece of art. So no matter what you do, even if it's a storybook that you're doing, we'd like you to include what's called an artist statement. Now, for those of you who don't know what an artist statement is, normally when you go to an art gallery or museum, you often have a piece of artwork or a sculpture or something, and next to it we'll have a little written blurb that is from the artist, where they say, look, the reason why we've created this is what it's about, this is the themes that we think are important. So it's basically what you want the audience to draw out of that artwork. So we want you to do the same thing. We want you to record a short statement. It can be, we'd like it to be recorded of you speaking it to the camera. So recording that statement that people watch before viewing your retelling in whatever form that might be, story, you know, artwork, dance, whatever that is. And it should include the following information. It should provide a context. So who's this story from? What community is it from, if you know? And it should also, you might even want to put a summary of what the story is about if you're doing a dance or a music piece. What you're hoping to learn, the audience will learn from the story. So if it's explaining the life cycle of an animal or predicting a weather event, you need to kind of spell it out. Normally, an artist statement wouldn't necessarily spell it out, but we'd like you to spell it out for us. So, and then what we'll do is in the last session, we'll share a few of the projects from some of the schools, and but everybody's story will be up somewhere for you to view. So, to summarise, what we'd like you to do: find a story you'd like to share, retell the story in your own way, record a 30-second artist statement to go with your retelling. Okay, so that's kind of what we want you to do. We also just want you to just bear in the back of your mind, just any cultural sensitivities, be mindful of the knowledge that you're sharing. Make sure that when you're retelling this information, it's respectful and in the spirit of the original oral tradition or the original story that you're telling. So, just bear that in mind. We are trying to be respectful of the stories that we're retelling and telling them the best we can. Mm-hmm. Yeah. Okay. Any questions about that? Oh, and I just saw from Venimo Secondary, if I were an object in the sky, I would be the full moon, so that I give light to everybody. I love that.
Very wholesome.
That's beautiful. I hope you'll be the full moon too. Okay. Excellent. Oh, hold on. There's another one here. Team Passam, Rosalind want to be a star so she can light up the night sky and twinkle and give up different colours.
Yes, own the spotlight.
Yes, and also a little bit of a spoiler for different coloured stars. I'm sensing a bit of a person who knows a little bit about the stars. Awesome. Yes. Good. I love it.
Things to look forward to in today's class, actually.
Yeah. Okay, excellent. So there's no questions then? We're all good with that project of what we'd like you to do? I'm really excited to see what you come up with.
Yeah.
You know, I know I've been emphasizing like dance and art and stuff. You don't have to. You can just do like a storybook, but or even just like a little reenactment. That's fine. Yeah, so just don't feel like you have to go and create a dance. But if you do, I would love that. Just saying.
Yeah.
Okay, right. Let's get into the meat of this lesson now that we've done that. Sweet. So, Crystal, do you want to take it over?
Yeah. Awesome. So, can I have the keyboard?
Yes, you can.
So today's lesson, essentially the focus is talking about the longevity of oral traditions. So longevity is, we're just trying to highlight that Aboriginal culture has a very long history here in Australia, tens of thousands of years, at least 65,000 years. That is a number that always expands. And so today I want to show you some of the stories that we know have been described over up to thousands of years. And also want to talk about variable stars, which will be a point of interest. So we're going to start with variable stars, exploring the top ones about Naruna and Gambaguda, and also the Pleiades, or the Seven Sisters. We did talk about them a little last time. And then we're also going to have a look then at the longevity, so looking at these stories that happen over amounts of time, that, you know, significant amounts of time, not something that you can just see every night, you know, something that requires separate observations and storing of that memory. So looking at eclipses, supernova, meteorite impacts, and something called precession, which, I feel like most people I'd speak to don't know what that means. So we'll all learn today. So I wanted to start off with variable stars. And we are actually going to have a little bit of an observation session with you all. We're going to play a video, no audio, of a variable star. And there is a part in your workbook task 1, from memory, where we want you to follow that prompt that's on there and note some of your observations about the video we're about to see.
Yeah, so you might want to write down about 3 things that you observe happening. So you really got to put on a bit of your scientist hat with this to kind of think, okay, what am I seeing, what am I observing? Don't try and explain it yet, but we would just want you to try and make those observations. Okay, so let's watch this video, watching very carefully.
Not a whole lot happening at the start.
Well, there's a few things. I've made some observations. Cool. Okay, right. So what did you notice? So let's have it. Maybe I'm wondering what's the easiest way to do this. So far, we haven't had many people unmuting themselves. So let's just stick with the chat feed for now. I'd like people to just in the chat feed quickly jot down one thing that you observed, and we'll have a see what you guys have come up with, because maybe what we've come up with is different to what you've come up with. So let's see, what did you observe? It's interesting, Crystal said at the start, nothing really is happening. But then things did happen. So. Flaring. Okay, we have flaring. Yeah, so at the start, there was flaring. There was, if I'll play this video again and pause it, you might see and there's nothing happening. And then, no, I don't know. Was that it?
Well, we had some.
We had some happening. You might see, like if you, Pete, sorry if I could just put this on. You might see a tiny little flare just there. That happened. Okay, so we've got flaring. What else did we see? Explosions on the surface. Are those the ones that you meant, that want those sorts of things, Isabel? These sorts of explosions on the surface, or do you mean like the changing surface here?
Oh, explosions on the surface. Interesting. So it could be the flaring again, or maybe having a look at some of that detail.
Yeah. Okay, what else did we see? Maybe once we got to about the halfway mark, I think it was, about here. What do you start to notice about it? Probably about this point here. Anyone notice anything? Compared to this? It's a bit bigger, isn't it? So it's changed in size. So we've got this change in size. Okay. What if we go a bit further across? Then so the closer it glows with fiery colors, and as it goes back, it turns white-like. Oh, I like this. So you're getting this, it goes from like this golden color with fiery colors. I like that word that you use, fiery. And so one of the things I'd really encourage you to do is when you're talking about colors, try and be really specific. Fiery, I understand what you're saying, but you're talking about yellows and reds, yeah? So try and say yellow and red colors. It was a yellow color, a red color, and then it turned to a, whoops, I've lost my thing, turned to a whitish color, which, you know, a whitish color. Would anybody describe that? It is very white. If you were to give it a color, what would it be closer to? Like a, perhaps you could say it might be a grey or a blue white. Okay, I'd probably suggest maybe a bluish color. But yes, and it definitely is a ball of fire floating in clear space. It's surrounded by a lot of nothing. And it's actually really interesting when you talk about stars, they are often surrounded by a lot of empty space. Yeah, okay, excellent. So after it goes blue, then what happens? It's like a sky blue. Yeah, it is. Yeah, it's a very pale blue. Beautiful. Then what happens? If we were to describe the size of this, how would we describe the size of the blue star compared to the yellow? I'm hoping most of you are probably thinking, it's changed size. Yeah, it's a lot smaller. Okay. And then after it goes from that blue, sorry, I can't quite find the blue color, there it is. Then it goes back to being yellow is bigger. Yes, Paulini, that's right. Pauline, that's right, yeah. The yellow does tend to be bigger. Okay. So this is an example of what we call a variable star.
So when it comes to stars, and I don't know if you've ever seen before something like that's called a Bunsen burner. I know I saw them for a brief time when I had a chemistry class, but essentially it's something that gets you sort of familiar with flames and temperatures and their colors. And so, you know, I'm so used to associating blue and white with the cold. That's what I sort of think of. I think of icy conditions. But when it comes to like fire and when it comes to stars, it's actually the exact opposite. So the redder, more yellow, red, orange a star is, it's actually far cooler in temperature and far less bright than a star that is blue. A star that is blue or white is very hot, very bright, and also will live a very short life, which is also fascinating. So we have some pictures on the screen here to show you the way that we actually classify stars. So we can actually sort of separate them depending on their color and their size and temperature. And so we can see over here, this is our MK type stars. These are dwarf stars. They're the smallest stars in the universe. They are so dim that they are just pretty much impossible for us to see from Earth with the naked eye. It's just not going to happen. As these stars are around 3,000 degrees. So it's funny to be calling something that's 3,000 degrees cold, but this is sort of more like a colder star. Here in the middle, this is G and F type stars. These are the orangey yellow looking stars. And these are actually what our sun is. Our sun is actually a G2 star. So it's sort of like the Goldilocks zone of stars, that perfect little zone of not being too hot, not being too cold, being a really good star for life to develop around it, to be able to have water exist in all the states of icy, being frozen, being liquid, and being gas. Then over here we have our OBA type stars. So these are very hot. So this is essentially 3,000 degrees for the red, 6,000 degrees for the orange, and then we jump all the way up to 30,000 degrees in temperature for these blue stars. So they are phenomenally hot and very bright. And as you can see down here, we've included to show you also the sizes of these stars. Because if we see these stars in the skies, a red star, they're not going to be commonly the same sort of size. Actually, in this case, our red stars are the smaller ones and our blue stars are the bigger ones, which might interest you because in the chat we're saying yellow's bigger. But in these examples I've given, yellow's actually smaller.
Yeah, I was going to ask about that.
Yes. And so I guess I'll jump onto the next slide that sort of explains it a bit better. So, okay.
Whoops.
I've done classic Luke.
Okay.
Perfect. All right. So so what's actually happening in that video that we're seeing is we're seeing a star that it's actually quite hot. We started off with something that was sort of red and orange in color. I guess a good way of focusing it is that we can say, cool, we start off with a star that's actually sort of larger. So over here, it's sort of was our little pointer. But we have a red star that's sort of large and it's cooler and it's looking red and orange, not as bright. And so stars sort of operate the way that I would describe with my own sort of human body to give as an example. So for example, if I'm like, if it's a hot summer's day and I want to cool down, I'm way less likely to rub up. Pete? Sorry, could you please? Hi. So if it's summertime, it's going to be really hot. And so I'm less likely to sort of be like this if I want to get cooler.
If you want to get cooler.
If I want to get cooler in this hot temperature. So what I would more likely to do is just sort of open up and air out. And that's sort of what's happening with our stars. Our stars, when they're all condensed and small, so like when we saw the blue one, it's really nice and hot. But when stars expand out, they start to cool down. It's like sort of airing themselves out. And so as they expand and get larger, they're cooling down. And so they're actually turning more red in color. And they're also getting less bright. And then stars, when they start to contract again, we're closing in. I'm getting all rugged up. I'm holding myself tight and putting on my blankets. And I'm creating a lot of warmth. It's a similar thing that we're witnessing, at least with these stars. When they get all nice and contracted, the pressure's really increasing inside these stars. The temperature's really climbing. And that's where we see those blue colors again. And so these are a very special type of star. It's not like our sun. Our sun is not a variable star. It is this yellow orangey color for most of its life. It's like 11 billion years. And it won't expand until it dies, which is a very long time away.
So some stars out there are changing size and they're expanding and contracting and changing. As a result of that change in size, they're changing temperature.
Yeah.
But other stars out there are just staying the same size for most of their lifespan.
So these are very special stars, variable stars. They literally change color and temperature just because they're expanding outwards or they're contracting inwards. And so that's what we were seeing with that video. And you can see here we have a diagram underneath these colors. So we've got the red one being larger here. And we can also see that this axis for brightness has it as a pretty low brightness. It's down here.
And brightness probably also equates to temperature.
Yes.
Yeah.
In astronomy, brightness, temperature, and color are all very closely related. So that's what we're witnessing in this one graph. It says brightness, but really it's also color and it's also temperature. They're all very well connected, just like our knowledge is.
So as the star gets brighter, okay, and warm and hotter, it also changes color. Okay, so that's what we're seeing here. It goes from red to yellow to blue. And then it will start to increase in size again. And as it increases in size, the brightness starts to dim, the temperature starts to lower, and then it cycles back up again.
Yeah.
Okay, so that's what we call a variable star.
And so these are described in a lot of Aboriginal astronomy stories. And so today we're just going to share a couple of them so you can see the ways in which you could describe a phenomena like this, but in that traditional way that we're used to, where we create a story around our science so that it's in a more interesting format that we can make as simple as we want, we can make as complicated as we want, and I can teach it to Miss Boney, or I could teach it to my 5-year-old niece. You know, we can change how complex these stories are. So I wanted to start off.
Yes.
And do we need to prompt anything about the workbook?
Look, in the workbook, there is a little activity there. If you wanted to be taking notes, you can jot down. It's got that exact same graph that we just went through. It's just asking you to colour in the stars and label which one's going to be hottest and which one's going to be coolest. Okay. So if you're playing along at home with the workbook, you can do that as well.
So I wanted to talk about 2 characters which are called Naruna and Gambaguda. So this is a story that is a Kakatha story, and it focuses on a constellation that is seen by communities right around the world, which is this sort of shape of a man in the sky, commonly known as Orion. In this case, in the Wiradjuri traditions, it's Byami, and we can see this is the reason it stands out so well is essentially because we've got these 3 stars here that make Orion's like a hip line, or commonly referred to as Orion's belt. So it's like if he has a belt around his waist.
Has anybody, do you all know of Orion's belt? Have you seen it in the sky yourselves? If I can see your videos, give me a shake of the head if you have, yes or no, maybe. Has anybody seen Orion's belt before? Yeah, a few of you. Yeah, excellent. I can see a few shakes of the head, yeah. If you haven't, I'll leave you, you haven't, yeah. Go out and have a look at it. Hopefully you'll be able to find it. Once you see it, it's very hard to unsee. Yeah.
It's my favorite. It is my favorite feature to find in the skies because it can help you see a lot more as well. But at least in Melbourne, this is a special constellation. It's called an equatorial constellation. And that just means that since it's closer to the equator, not down in our southern skies necessarily, we only see it for certain times throughout the year. So this is a summer constellation for us. So I'll look for
probably
it.
Probably in PNG, it's probably
consistently up. You would see it way more than
all
us.
the time. Yeah. And it's really interesting that despite, Orion over on the far left here, that's a Greek myth. And when we talk about it with Naruna and Gambaguda, it's also the shape of a person as well.
Yeah.
Yeah. So, that's really interesting that 2 completely different places on Earth still view this constellation as a person.
Yeah, it's remarkable, I think. And so we're going to be focusing in particular on the star that's contained within the right shoulder of Orion. So this is how we would see it down here in Melbourne, that he's sort of falling across the sky. And in this part, this is what you would see in the northern hemisphere. And this is his right shoulder. So it's just the flipped versions. And we're essentially looking at this star, which is called Betelgeuse or Betelgeuse. In particular, it's our star of the show, very literally. So this is a Kakatha story. This is a group around sort of Adelaide. For us, this is in South Australia, so not nearby where Miss Boney and myself are. And it talks about the main characters being Naruna, so this Orion figure with his this special star in his right fist, Betelgeuse. Then we also have Gambaguda as the next main character, and she's in this constellation Hyades. It's like Taurus the bull as well, if this is like the upside down V of the bull. And the star to focus on in that case is this star down here. This is Aldebaran, and it's said to be in her left foot. So we have a special star in her left foot and a special star in his right fist. And then over here, if we follow along, these are the Eucharia sisters, or otherwise known as the 7 sisters, or the Pleiades. So we've discussed them in the last lesson as well as this one. And so the story talks about Naruna being this very hard to get along with person in the community. He's not very nice and quick to aggression and likes to use, this special star, it's a fire magic that he contains in his right fist. And he likes to use that to try and intimidate people. He decides to essentially hassle the Eucharia sisters. He thinks they're very cool, wants to hang out with them. They do not think he's cool and they do not want to hang out with him. And he gets very angry about that. And so their older sister, Gambaguda, she decides to sort of stand in and tell him, no, okay, you have to back off and leave my sisters alone. And so he gets very angry and very quick to anger. And so what he does is he summons this fire magic in his fist because he's like, yes, the way I handle this issue is by striking with my fire magic instead of...
We do not approve of violence.
We do not approve and we do not condone it. Nirina is a silly character.
No.
And so essentially he summons this fire magic and he goes to take a strike at Gambaguda. But she is not defenseless. She has her own tricks up her sock, not her sleeve. Sorry. She has this fire magic in her left foot. And so what she does is she summons it too. And instead of fighting him, what she actually does is she just kicks at the ground. She kicks at the dirt. And it sort of pushes it all up into the sky and it gets in his face. And the whole point of that description is to show that she used a not as violent way of dealing with the situation. And because it's a pretty simple way for someone who's this big, strong hunter type to be taken down, he gets very embarrassed by that because, you know, he's fought countless people, animals, whatever. And then all of a sudden this dirt comes and he's completely embarrassed and needs to sort of back away. And so with that embarrassment, we have his fire magic die down. He has no more fire magic. Seeing the peace and that he had left, Gambaguda lets her fire magic die down too. So fire magic is gone from both. Over time, Nirina gets angry again, and he thinks it's a bit ridiculous that he was thwarted or he'd lost to Gambaguda. And so he summons his fire magic back in his right fist. He's like, no, all right, didn't learn my lesson the first time. Let's try this again. So he goes up to Gambaguda. Unfortunately, this time though, Gambaguda is unable to summon that fire magic in her left foot. So what does she do? Well, she calls upon a father dingo named Papa, and we can see it in the picture here, and his dingo pups. And they make up what, Western astronomy thinks of as Orion's shield. So this is like Orion and his shield. He's an archer. But these are the dingo puppies. And once again, it's sort of not what you would expect. Instead of these, Nirina fighting against all these dingo dogs, instead they just sort of come up and they bite at his heels and not enough to hurt him, but enough to force him away. And once again, it's a sort of embarrassing way for him to lose. And so with that embarrassment, his fire magic dies down again. And so this is a cyclic story. That's what we use to describe stories that continue to go on for forever, just in this repeated sort of cycle. Nirina, he summons his fire magic when he's angry and he goes to take a strike at Gambaguda. Most times, she can summon the fire magic into her left foot and strike back. Sometimes she can't, and she has no way of summoning the fire magic. And so she just relies on the people in her community, the dingo pups nearby, to be able to help her. And so the focus is describing what's happening to those stars. And you might be sort of starting to piece things together. We're talking about these variable stars before, about these stars that get bluer in temperature and also get very bright. And then when they expand outwards, they cool down, they get dimmer. We're not seeing them as well, and they're getting very red and very orange. And so in this story, that's what it's describing. It's describing the dimming and brightening of those stars that make up those people in that constellation. And they've described it in such a creative way that it's a fun story that we can tell, and we can make as simple as we want, make as complicated as we want to describe the way those stars are changing.
So it's really interesting. And what I'm curious to know is how often do you think Nirina's fist and Gambaguda's her foot, how often are they varying, do you think? So in the chat feed, just put a guess, how often do you think that because we know that some of the times they're getting brighter and sometimes they're getting dimmer. What do you think the frequency or the interval between those brightening and dimming episodes is? I'm really curious to know how fast do you think it's happening? We're talking minutes, hours, days, months? How often? Years? If years, how many years? I want to know. Have a. What do you think? What's your instinct telling you? I mean, this story. Based on what this story is, how often do you think these dimming events are happening? Seasonally, I like that. Yeah. So maybe 4 times a year.
It sort of buys into what we were saying before about how these are constellations that we don't get to see in the sky all the time.
Yeah. Anyone else want to have a guess? If you're going out there and looking at the night sky and watching for these brightening and dimming events, you'd think, fairly regularly, at least, yeah? Yeah. I'm hoping you're all, because I'm not getting much in the chat feed at the moment, I'm hoping you're all having a bit of chat at home. So how often are these dimming events happening?
Well, the period of time can change depending on what stars. In this case, though, these dimmings are happening over the course of years, of a few years.
So when you say these dimmings are happening over the course of years, you mean like Niruna's fist will flare up for a couple of years and then dim down for a couple of years?
It's sort of like
or it'll get brighter for like a little bit and then...
They're very subtle changes. So these can happen over the course of a year, maybe a few years, and it'll happen slowly over that time as well. Sometimes it can just stay consistent. It might just stay the same for a bit, but usually these are very subtle changes. And so it's something that you need to be paying careful attention to over a long amount of time to be able to notice. And what's interesting, I guess we can skip to some of the slides to talk it through. But in this case, here what we've included is a graph that us astronomers look to. And this is actually just plotting or having a look at the changing in brightness over time. So down here, it says Julian date. This is just a way of looking at time passing. So we're very used to saying that the year is 2022. So this might look a little bit weird to us to see the years in the what is that, 2 million? 2,448,000. So it's a bit different, but it's essentially, or maybe that's days. Okay, anyway, might be days. Anyway, essentially the main thing is looking at the fact that this is measuring brightness. So we measure brightness in what we call magnitudes. And as astronomers, you might notice that this is inverted. So the smaller numbers here, the bigger numbers down here. So 1 versus 0.2. In astronomy, when we use the system of describing brightness by these magnitudes, we actually have it that the smaller the magnitude is, the smaller the number. So if it's a 0, it'll be a far brighter star than a star that has magnitude 5 or 10. So essentially what we're seeing here is that over this course of time, and I think this was dates because I think this worked out to be, we'll look at a better graph in a sec, but I think it was like a few years down here. But essentially you can see that Betelgeuse is getting bright over time and then dim once again. And then more times passing, it's bright, no, it's dim, no, it's bright again, up over here, and sort of jumping around. But what's more interesting, and this one is a bit easier to read, is having a look at what is happening to both of the stars. So not just Betelgeuse up here, but having a look at what's happening to Aldebaran, the star that was in Gambaguta's foot as well. So in the story, it was talking about how Betelgeuse, or at least Niruna, was able to summon his fire magic back pretty regularly. He was always ready for a little tussle. And you can see here that that's reflected in the brightness of the brightening of that star. So from here is 1990 to 1997, 2003. So we're sort of jumping up on these increments of around about 7 years each time. Here's like 6 years, but it's approximately 6.5, 7 years. And never mind. And you can see that over that course of time, how often these variations are happening. This is a different scale. This is between 1997 down to 2003. So that's sort of like this chunk here. But even then, we can still see that in the case of Aldebaran, so the star in Gambaguta's foot, sometimes it's bright and then dramatically dipping and then back to bright and then dipping. And then there's not a whole lot of change that then happens for extended amounts of time over here. So it's very inconsistent, it's very irregular, it's hard to predict, but it is changing. And I feel like that is captured very well in that story by talking about when Gambaguta is able to defend herself and other times when she is unable to do so. This one we'll go over quickly, not in as much detail, but another example of possible variable stars. So this is just something that I've done in my research with some of my supervisors who work a lot in this field, but it's not something that's published. So it's just something for your interest, but it's nothing to be taken. Yeah, no. That makes sense. Sorry.
It's still being...
It hasn't been published, but it's very interesting. So the Pleiades, or the Seven Sisters, as we've described sort of in the last class, they are noticed by cultures around the world. And they have sometimes a very similar interpretation where they're seen as this group of young women or group of sisters that are in the sky. And so there are a number of different stories which talk about these sisters and about something sort of happening to them in their lives that impacts them. So quite often a sister is, for example, in a story, they'll talk about the younger sister being kidnapped or maybe fell ill or maybe has passed away. Something has happened to her. Maybe she's hiding behind her sisters, where she's a bit different from the other stars in the sky, the other stars that are with her. And so it's fascinating because all these stories right across, in particular Aboriginal Australia, but also around the world, describe this happening. So it's sort of like, well, is this a coincidence that all these different groups are saying something's happening to the youngest sister, so the least bright of the sisters? Or is it just a coincidence, I guess? Or is it telling us a bit more about what's happening to that star? And so what's really interesting is it seems to be describing a variable star in the way that it's saying something happens to the sister, she's changed in some sort of way, she's either getting dimmer, losing a bit of her fire, losing a bit of her frost, depending on the way she's described. And when we actually have a look at the stars that make up the Seven Sisters, we notice that they all have some type of variation. And in the case of these particular stars, so the 7 to 8 brightest of these stars within the Seven Sisters, Pleione, which is the 7th brightest star of the Pleiades, most often thought of as that youngest sister, does actually vary in her brightness. And it's on the scale of 0.4 magnitudes, which is that thing that I spoke about before. And the reason that it's important to at least know that number is because for the human eye, to be able to detect these changes on our own without needing fancy telescopes to help us, we need to see a change in about 0.1 of a magnitude.
Okay.
So in this case, we have 0.4, which is 4 times what the human eye requires. So these are changes that we would actually be able to see. And what's crazy when it comes to this story in particular, and why it's still a work in progress, is that the period of variation, so how often this Pleione, that star in the Seven Sisters, varies, is actually on a scale of around 34 to 35 years.
So that's almost half a lifetime.
Half a lifetime. This is something that these stories, particularly when it comes to Seven Sisters, they are so old around the world. I know that there's some pretty crazy dates for how long these stories go back. So it's something that, communities are looking to, respecting, especially Seven Sisters. They are very commonly associated with like women's knowledge, women's business for a lot of our communities. So it's a very important constellation. And and appears
observed so closely for so long that they know these constellations so well that they can detect these changes over a period of 35 years.
Yeah.
And they're kind of recording that, which is just incredible. And I just think it goes to show that longevity of how long this information, not just in terms of how long the information itself is stored, but how long this information is being recorded actively recorded, I think is what I'm kind of getting at. Yeah.
And I think it's cool too because variable stars are so subtle. So it's something where you have to pay attention not just to the star itself, but the stars around it to get an idea for how its brightness is changing over time. And there's heaps more stories about variable stars in Aboriginal traditions, but these are the 2 examples that we're going to focus on for today.
Yeah.
So now we have...
so there is another activity in your workbooks that if you can go back and just have a look and have a think about what you're seeing in those graphs. I think it's really, really cool.
Yep. So we have 13 minutes left of class, and which is quite fitting because these topics aren't to be explored necessarily in depth. It's to show you the timescales that we're dealing with, to try and get across how long these stories have been kept for, how long they've endured, and just I honestly find it mind-blowing. And I know for people who aren't used to oral cultures, it's probably a bit shocking because we think that we have very short memories and I forget something as soon as I leave a room. But oral cultures handle information very delicately and with a lot of purpose. So I'm going to try and blow your minds with some of these examples here. So I wanted to start off by talking about eclipses. So there is a story from my community about our beautiful moon man Baloo, as well as our sun woman Yi. And so this is a common technique when we talk about different objects in the sky by assigning them a character in these stories so that they're interesting, easy to remember, and we can describe the way those objects move by describing the way the characters interact. And so in this case, it talks about the beautiful moon man capturing the eye of the sun woman Yi. She thinks he's gorgeous. And so she decides to pursue him across the skies. But the thing is, he's not very interested. And so he's trying to get away from her. She's sort of,
she's playing hard to get.
Oh no, she's after him. He's like, oh, I don't know if I don't know. And so what he decides to do is he zigzags across the sky to sort of just escape her attention.
Oh, sorry, he's playing hard to get.
He's playing hard to get.
He's like,
she is besotted. She thinks he's gorgeous.
Yeah.
And so it's interesting because we're talking about this zigzagging nature, and this is something that we we see the moon do. So it doesn't zigzag throughout a night, but if you were to look at where the moon is across a year, you would see sometimes it's sort of below the sun's path across the sky. Sometimes it's a bit above it.
Did we talk a bit about the sun's path last?
I don't think so.
I don't think so, yes.
And I think it's in the very last slide. So
yes.
but it's not necessary for you to absorb that detail, but it's just to say the way that we can describe the way those objects or characters are interacting, we can describe specifics about what's happening in the sky to do with them. And so the story says that after a certain amount of time, the moon man Baloo looks at the sun woman and he's completely enamored. You know, he thinks she's gorgeous in return.
He changes his mind.
He changes his mind. He's playing hard to get, but he's fallen in love too. And so he decides to cover the sun woman in an embrace, so like a hug, which is a description for the moon covering the sun, which is a total solar eclipse. And so these might be more frequent in your part of the world, closer to the equator. But where we're from and where this story is from, they are very rare. And so these types of stories can occur sometimes up to these types of events, can occur sometimes up to 400 years in between. So this is an example of a piece of phenomena in the sky that you either need to have seen for yourself to be able to talk about it, or someone else's need to have seen it and taught you about it for you to know it exists. So it's sort of a shorter example, honestly. Like we looked at something that was 30 years before, now looking at 400 years, but these do continue to increase. So now,
supernova.
So now I want to talk about supernova.
I feel like we need a soundtrack to go with this. Like we have supernova song. We have total eclipse of the heart song, total eclipse of the heart, and then we can have a supernova song.
Yes, we should be communicating through song. It would be very effective.
We really should be.
Probably stick in your brains better as we learned about memory.
Yeah.
So supernova are the really cool, fiery, explosive death of very large stars. So I said before, we looked at those beautiful blue stars that were huge and very bright, and I actually said they didn't live that long. So it's sort of funny how in the universe, the bigger the star is, the shorter its life is going to be by a lot.
And the more elaborate its death is going to be.
The more dramatic.
Dramatic. If you think of our big, bright, hot stars, they're like, I'm going to be here for a very short amount of time, and then I'm going to go out with an absolute bang, you know. They live their lives hard and fast.
They do.
They do.
And so when a star like this explodes or into a supernova, when it dies, it's something that we would be able to see very clearly in the sky. And so we have a story that's from Yalnu country, which for us is up in Northern Territory, Arnhem Land, which talks about the emergence of a supernova in the sky. So this essentially having a dark spot in the sky that is taken over by a very large, very bright star that sticks around for quite a while. It's not something that only lasts a few seconds. These things could be in the sky for months. And they described its exact position and have told this story for a long while. But they were also not the only culture in the world to have described the same appearance of a big bright star that emerged for a short amount of time before slowly fading away. Another culture that saw it were ancient Chinese astronomers in the exact same spot of the sky. It's actually in the constellation Scorpius. I always have to remember which one's the astrology one, which one's the astronomy one. Around the pointers of Charlotte and Lassath. So this is essentially in this area here. It's actually in the Milky Way, the banks of the Sky River. And so what's fascinating is when that was observed in the ancient Chinese record, this event is dated back to the year 393. So that would be almost 2,000 years ago. Supernova are pretty rare. I think the last one, I might be wrong, the last one I confidently know exists happened sometime in the 1800s. But ones that we've been able to observe, I mean, there's more happening in the universe, but ones that we can see from Earth in our skies, I honestly don't know of any that's happened even in the last century.
Yeah, they're pretty rare.
They're pretty rare, especially for us to be able to see them. They happen, the universe is huge.
They
happen all the time in the universe, but for us to see it.
Yeah, not visible to us.
And fun fact, that star Betelgeuse that we were talking about earlier is one of the main stars that is likely to go into a supernova in our lifetime. So it could be tonight.
Keep your eyes on Betelgeuse. It might go supernova any moment.
Yeah. But it'll be something that'll be as bright as the moon and we'll be able to see it in the daytime. So fingers crossed, because I love Betelgeuse, but I would love to see it.
You love Betelgeuse, but you really want to see it die.
I do. I need to experience a supernova. So they're very cool. Very fiery deaths. I don't know if we have enough time necessarily. Well, okay. This is a video of one occurring, so you can see just small star.
It's CGI.
This is CGI.
Yeah, it's not.
This is all generated. I apologize. That happens a lot for us in astronomy. But you can see that essentially it's a small star that explodes into a huge thing, leaving behind what we call a planetary nebula, which is so silly because it's got nothing to do with planets. And I spoke about that on the news, which is why it's on my head. So essentially, 2,000 years is what we're looking at in this example. Now I want to talk about meteorite impacts.
I love this story.
So we have stories from Central Desert in Australia, Alice Springs area, a bit more specifically close to, relatively close, it's Australia, so 125 kilometres. But we have descriptions of things like fire falling from the sky that have completely scorched the earth and left its mark on the earth for a very long time. And so the focus here is on this part in particular. So you can see that this is all sort of dry, arid sort of looking landscape. And then in this center, there's this beautiful green looking little valley. Well, I don't know what the right word is for it, but this little beautiful green lush area. You can see that sort of dips down. And so what this actually is a meteorite crater. So these stories that come from this community back when Australia had first been colonized and people started trying to explore across Australia, scientists who came to this Henbury site were warned by community, don't come any closer. This is a site of significance, site of respect, back, long time ago, as a sort of punishment, which is sort of like a weird thing to say, but we're talking about social values, and you think about nursery rhymes, or fairy tales,
with a warning,
which tend to be sort of, you have like the Disney version, which is very lovely, but actually most of these fairy tales have been written with some sort of moral to the story. So they have some sort of thing they want you to gain from it. This was associated with that too, of saying that, a taboo was broken in the community. And so this fire came down and scorched the earth as a warning of, don't break that taboo, to learn from it. And so it's fascinating because we can then date these sites. And so when we've actually dated the sites, the Henbury crater sites is over 4,500 years old. So fire falling from the sky enduring in these descriptions up until present day. And then the final example I wanted to give for the longevity of Aboriginal astronomy is talking about something called precession. And it's focusing on the First Peoples of Tasmania, which is about as far as you can get away from PNG in Australia. So heading towards the South Pole. The little island essentially at the bottom of Australia. And so the First People of Tasmania. And so they have stories. I just want to see what I have available. Okay, this might be, essentially, our Earth is on a 23 degree tilt. And you might jump back to me, it might be easier to describe instead. So instead of the Earth being up like this, nice and straight and orbiting around the sun like that, instead the Earth is actually on a little tilt, a 23 degree tilt, and it goes like this, which is how we get seasons. It's all to do with how much light is hitting the Earth. And so if the sun's here, and this down here is the southern hemisphere, here's the northern hemisphere, in the wintertime, the southern hemisphere is pointed away from the sun. So we're just pointing out to the universe, it's going to be completely dark at the South Pole, completely cold. In the summer, when we orbit away around the sun and we're keeping that same sort of orientation, because we don't change at all, we stay on this tilt, we're now pointed towards the sun, which is why we get such long days in the summer and why it's so hot, because we're getting all that sunlight, and why we won't have any nighttime during summer at the South Pole. So what happens with this is that we have a toy that's called a spinning top, which is quite common. Sometimes you see it.
I've played with spinning tops before.
Around the world, but it's essentially like this little triangle sort of thing at the bottom with a little stick. And when you twist and spin it, if you do it fast enough, it's going to sort of spin really quickly and stay upright. And as it starts to slow down, it starts to sort of fall. But also what it's doing is it starts to change the orientation that it's pointing in, like that, slowly over time. It's very fascinating, spinning tops. And that's actually how the planet works. That's how the Earth works as well, but on very long time scales. So it's approximately every 26,000 years, the Earth will do one full rotation of slowly facing a different part of the night sky. It's a very long amount of time.
So it's what you're saying is that if this is the sun and this is the Earth on its tilt, at some point over 26,000 years, it goes from being on this angle, sorry, my top's a bit coloured, to being on this angle.
Absolutely. So every 13,000 years, we are facing at a completely different part of the sky than what we've been used to. And so what's fascinating is that we have really detailed stories from Tasmania, which talk about there being certain features in the sky, as well as Tasmania being connected to physical Australia by ice mass. So we can use geological evidence as well as astronomical evidence to get an idea of when these stories might have existed. And so this story in particular actually indicates that it originated, please let me skip over, that it actually originated over 16,000 years ago. And we have even bigger story lengths as well, but things that don't relate to astronomy, so I wouldn't have taught about in this class, but really detailed descriptions of volcanic eruptions that changed the landscape on country. So being able to talk about sort of the time before and the time after, which we can also then date the volcanic eruptions and find that they are over 38,000 years ago. So we have stories that just capture historic events that is just honestly absurd, but very cool and very fascinating. And so that's...
Yeah. So I think what's really interesting is to, when you are looking at stories in your own local community, is to think, well, I wonder when this story was created. I wonder how old this story is. And maybe, some stories you can't date, but maybe some stories actually could be dated if we looked at other information that we have available to us now, maybe information that we didn't have available to us, 100 years ago even. So I'd really like you to think about that when you're listening to these stories and considering just, not necessarily just taking the story on, okay, what information does it have in it? I mean, that's important, but also, I wonder when this story was created, why it was created, and how long ago was it created? I think that's a really interesting question to ask.
Yeah, I agree.
And I think one of the reflection tasks for this lesson in your workbook is to think about what we've talked about today and maybe what we've learned. I'm not going to get you to do it now because we have kind of run out of time, but I would love for you to do this if you have time after this is finished. What did you learn? Was there anything in particular that stood out to you? If you had to share what you discovered today with a friend, what would you want to tell them? What's important? Was there something that really stood out to you and something that you'd take home and share with your friends and family? So, we hope you've enjoyed the session today. Before we leave, was there any quick questions from any of the groups? Could be to do with the content that we've covered or even the project that we've got going.
I just wanted to mention that after this workshop, there is a bit of time. There's a few weeks for you to actually be completing your project. And so it's not actually due for submission until the 1st of September. There we go, Brett. So 1st of September, and then we will regroup on the 8th of September and all come together for another workshop to showcase that your submissions with Jade and Crystal as well. So a bit of time between.
Perfect. Awesome.
Excellent.
Well, then we appreciate you your attendance today and really hope that we've been able to teach you something that stood out for you. I mean, I'd be pretty interested to see what did stand out to you. So if you have to fill in your workbook, maybe next lesson we can
have a chat. I'd really love to know what you guys got out of this lesson. And I'm so excited to see what you do for your projects. I'm like so excited. I can't wait.
It's always good to having a project that allows everyone to, I guess, lean on their strength and creativity. Yeah. So whatever works for you, we can't wait to see that. So very excited.
Yeah.
Wonderful. All right. Well, then I guess we'll see you at the next session.
At the next session.